Today we're going to look at two more functional groups. We're going to look at the aldehydes and the ketones. In an aldehyde and a ketone, they both have what we call a carbonyl group. Our carbonyl group we see here is a carbon double bonded to an oxygen. So both aldehydes and ketones have carbonyl groups. In an aldehyde, the carbonyl group is on the end carbon and only a hydrogen is attached to it. And then on a ketone, we have the carbonyl group in the center with carbons on either side. So aldehydes have the carbonyl group on the end. You can see here, no carbons on the other side, just a hydrogen. And here in a ketone, we have carbons on either side. Naming aldehydes, we take the E in the alkane name and change it to Al. So for the IUPAC name, for one carbon, methane, so methanol, ethanol, propanol, butanol. But for the first four aldehydes, we use the common name being formaldehyde, acetaldehyde, propionaldehyde, and butyraldehyde. So for the first four, we use the common name. For any longer chains, we change the ending to Al. So looking at this one, giving the IUPAC name, if I look at here is the carbonyl group. So it's an aldehyde because the carbon is at the carbonyl group, is at the end. And I see I have 1, 2, 3, 4, 5 carbon chain and one methyl group there in the middle. So you first look for the longest chain. So pentane for 5 carbons, and we change the E to Al. So pentanol. And then name and number the substituents by counting the carbonyl group on carbon number 1. So we'll number it as you can see here. Carbon number 5 is over here, 4, 3, 2, and 1. So that means the methyl group is on carbon number 3. So the name for this is 3-methyl pentanol. So let's practice a couple more. Looking here, here's my carbonyl group, carbon double bonded to oxygen at the end, so it's an aldehyde, and we have 1, 2, 3, 4, 5, 6 carbons. So that is hexanol, and I number my carbons starting 1. So this methyl group is on carbon 5, so we'll call it 5-methyl hexanol. Okay, the second example here, we see this benzene ring attached to the aldehyde carbonyl group. So this benzene ring is attached to the aldehyde, so it's known as benzaldehyde. And then the carbon number 1 is where the carbonyl group is attached. So 2, 3. So this one is 3-chlorobenzaldehyde. In a ketone, remember the carbonyl group is in the center of the carbon chain, and so we change the ENE the E and the alkane ending to ONE for the ketone. And if we have a common name, we identify the alkyl groups on either side of the carbonyl group and then add the word ketone. So we can use the IUPAC name or the common name. So looking at the IUPAC name for this ketone, I see here's my carbonyl group, but I have 1, 2, 3, 4, 5 carbons. So that is pentane, so that becomes pentanone. And then I have to give the numbering of the carbonyl group as well as the substituent group. So the carbons get numbered so that the carbonyl group gets the smallest number. So I number them 1, 2, 3, 4, 5. Carbonyl group being a carbon number 2, so that's 2 pentanone. And then the methyl group is at carbon number 4, so 4 methyl 2 pentanone. That would be the IUPAC name. So looking at the first one, it's a pretty simple ketone. We can give its common name. So looking at the common name, I see on this side is a methyl group, 1 carbon. And here I have 1, 2, 3 carbons on the other side. So that's a propyl group. So alphabetically, methyl comes before propyl. So we would call that methyl propyl ketone. The second example, because it has a substituent group, we can't really name it the same way, so we got to use the IUPAC name. So 1, 2, 3, 4, 5 carbons. So I've got 5 carbons. That again is pentane. So that is pentanone with the ONE ending. And I'm going to number it so that the carbonyl group gets the lowest number. I'm going to number it this way: 1, 2, 3, 4, 5. I could number it the other way, but that gives the methyl group a higher number, so we'll number it this way. So that's a 3 pentanone, and this on carbon 2 is this methyl group, so we'll call that 2 methyl 3 pentanone. Aldehydes and ketones are important in many different areas. The simplest aldehyde common name is formaldehyde. It's a colorless gas with a very pungent odor, but if we put it into an aqueous solution, it's called formalin, which is about 40% formaldehyde, and it's used to preserve biological specimens. So you may have dissected things in biology class before, and formaldehyde is commonly used to preserve them. It has a lot of industrial uses, making polymers like in fabric and insulation and carpet, plywood, plastics for like kitchen counters like Formica. We can have overexposure to formaldehyde fumes, can irritate the respiratory tract, eye, ears, and nose, and some overall fatigue. Some other important aldehydes is benzaldehyde, the aromatic aldehydes. So here we have the aromatic benzene ring, and here we have the aldehyde carbonyl group, and that's known as benzaldehyde. Here we have again the aromatic benzene ring with the carbonyl group. Also have an alcohol group over here and an ether on this side, so it's got quite a bit going on. But that's the vanilla, the aroma of vanilla and vanilla beans. Cinnamon, again, has that aromatic benzene ring attached to a double bonded chain, and there's the aldehyde as well. That's a ketone, I'm sorry, because you have another carbon on the other side. The simplest ketone is known as acetone, is its common name, or dimethyl ketone, a methyl group on either side. And here we have the methyl on either side of the carbonyl group. And you've heard of acetone before, used as a solvent, cleaning, paint remover, nail polish remover, all those kinds of things. So just to kind of summarize a couple of things, both aldehydes and ketones contain this carbonyl group, the carbon double bonded to an oxygen. It is strongly polar, so it's very aldehydes and ketones will dissolve in water for the most part. In aldehydes, this carbonyl group appears at the end of the carbon chain, and in ketones, the carbonyl group occurs between the two carbon atoms. In the IUPAC system, we get Al for aldehydes and ONE for ketones. And many of the simple aldehydes and ketones use common names, so it can get a little confusing.